Hey, welcome everyone, and welcome to SigNoz Launch Week. This is our second edition of Launch Week, and today we are presenting to you some of the cool features we have been working on around anomaly detection and alerts. I have with me Shrikant from our engineering team, who has worked on this feature, and he'll be presenting uh, how we thought about it, what are the key features, and what we have in plan around this feature in the future. So, Shrikant, welcome. Welcome to this webinar. And maybe you can quickly introduce yourself to the viewers.
Hey everyone, I'm Shrikant. I mainly work on metrics and alerting part of the SigNoz. I'm excited to walk you through the anomaly detection. One of many things, interesting things we have been working on.
Cool. So, I think till now we have been primarily working on fixed thresholds, and that's the only way users could have sent alerts to signals. And this is the first time we are generating more intelligence there so that people can add smart alerts and alerts which changes thresholds, like which are like intelligently changing based on like how the metric pattern is and metric data is, right? So yeah, maybe explain a bit on like what were the key thought processes going in building this feature, what were the customer stories which you're trying to solve, and uh, what use cases which you are trying to focus on in the first version.
Yeah, sure. So our users send us a lot of metrics. They come from various sources. Some come from their infrastructure components, and some come from the application components. Some are their things that they have manually instrumented to send their business metrics to us. And these metrics, they are not every metric. Like every metric, like there are groups of metrics. They show certain kind of like behavior with them, and some metrics they do not. Some metrics they're fine. They work fine with the the fixed threshold metrics. Say, like for example, take my CPU usage of my node or at my host machine. If it goes above 80%, that's something that I'm interested in knowing, and send me an alert that I'm going to work on. But not every metric is like that. There are certain metrics that that do not that show a kind of like behavior where you can't put a fixed threshold on it. Like for example, if we take a request rate that your web service like receiving, on the business day it might be receiving higher, even during the business day, and maybe at the particular time you may be receiving a much higher request. Take a, if you're a stockbroker, just as the market opens, you may get a lot of requests, and then it may play to like and then it may come down during the night. You will not see anything. So in such cases you can't put a fixed threshold on it, because because you cannot pick any particular threshold that kind of makes sense. That okay, if you put it lower, it's going to get alerted on the during the day. So in those cases it doesn't work well. So this is, and we have been receiving requests from users that hey, I can't use a fixed threshold alert and I need some sort of anomaly detection. So that's what kind of motivated us to start working on this.
Got it, got it. Maybe we can, so anomaly detection can be done in different ways. Like what was the specific sort of algorithm which we use, and what was the, if you want to explain a bit more about, I think you have a beautiful chart explaining that. So yeah,
Yeah, sure.
how does the underlying model work which we are using?
Right, sure. So right, so in the current anomaly detection that we like, the initial version that we are building on, uses like takes the data from the past, so that hey, like let's get the data from the past and see overall, see what kind of trends it is showing, and then look at the current season, and then the what the window that we are looking at, and kind of arrive at the value. So let's start by looking at from the so let's just say this is the, let me zoom in, and we are looking at a metric, that starts from, today 2 p.m. to like yesterday 2 p.m. to today 2 p.m. Just for the sake of an example. And if you see, if you can see some sort of pattern here, that okay, at 12 a.m. it goes slow, than comparatively, and then till 6 a.m. it kind of continues, and then it picks up again. So this kind of a day behavior. So where during the business hours it's kind of around 2 to 2.5k, but during the night it's around 1k requests per second. So how we arrive at the so this is the what the final results look like. So let's go look at how do we arrive at this. The green one, the dotted line, is the predicted value. There's an actual line, and then the upper bound, lower bound. So let's go look at that. So there are two things. One, where we try to get the seasonal growth of it. So how do we arrive at the seasonal growth of this matrix? So we look at the past seasons data. So when I say season here, if the seasonality of the metric is that it shows some seasonality and daily. So the past season is means past 1 day. If it shows weekly, the past season is past 1 week. So in this case, what we do is we look at the past season, like three
And
past
this
seasons.
season in the demo, I think you'll show that season is like you choose the season, like it's week, daily or hourly, whatever. This is something which users can choose what is the sort of time season which you want to specify, right?
Right. So sometimes sometimes you already know the like you as a owner of the application that's sending the metric, the kind of seasonality that your metric shows, and then we allow you to, okay, so hey, you use this seasonality to predict the value. Yes.
Got it.
Yeah. So in this case, so what we look at is we look at the past 3 seasons, and what we compute for the past 3 seasons is like get the at a higher level aggregation. So let's just say 1 hour aggregation interval past week, and then calculate the average of those values. Repeat the process for 3 seasons, like past season, past to past, and then before that. Take those 3 values and take the mean of them. So the reason why we do this is to account for the cases where if we just take past 1 season and then it turned out to be that was some sort of a holiday by the federal government or something of that sort, it should not be highly influencing the next season. So that's the reason why we consider past 3 seasons and they take the mean value of it, so that it becomes a better representative of the what was the like an average value of the past season. Next, what we do, we try to do the process, but for the current season. Okay, so if the seasonality is that daily, the current season is 1 day. So or if it's weekly, it's like 1 week. So we take the average value of the current season. Now we have the average value of the current season, and then we have the average from the past, like the mean of the past 3 seasons. And with using these two averages, we try to compute the seasonal growth. Okay, so what is the kind of growth I expect, like from the season to season? We use this seasonal growth component. So now I know that, okay, so this is the seasonal growth that with the data that I have available, we take that value and we use that. We have the current period value. So we add these two values, like the current period value, but the seasonal growth that we were expecting from the past data that is available, to arrive at this value. And if you see here, the value that here the seasonal growth is negative 0.35. For this reason, the dotted line is slightly below that. Like the predicted value says that, hey, like I kind of expect it to be a little lesser than what the actual value says. There are other two things that you see here, the upper bound and the lower bound. These are important because you want to have some sort of sensitivity to when you're setting an alert. Hey, this is so you kind of you get a score from the actual value and the predicted value using standard deviation, and you want to have some sort of sensitivity around, okay, if my actual value is like x standard deviations away from the predicted value, then alert me. And that x is something that you want to be able to configure. You may
Yeah.
want to be little if you keep it too high, you may miss everything, or if you keep it too low, you may get bombarded with a lot of alerts which you don't want. So you kind of have the ability to get that, I want to, hey, like how many standard deviations away from my value that I allow it to be, and if it's beyond that, send me an alert.
And how do you calculate the standard deviation, which impacts the upper bound and lower bound? Is it
So
just which period are you calculating the standard deviation for?
the standard deviation is using the previous series. So the standard deviation, so here we don't have the value, so it uses the previous series. So whatever the previous the previous window, that like, okay, so we are looking at a 1 day value, and then we look at the previous window of that to get the standard deviation value.
Got it. So the standard deviation also changes for each day. Like first, like for any
Right.
time, the lower bound or upper bound is based on the previous day's standard deviation. Is that correct?
Yeah. Yes, correct.
Got it. Got it. Cool. I think this looks pretty interesting. How does it look actually in the product? So you
Yeah.
explained what's the algorithm behind it, but I would now love to see how does it look in the product.
Sure. Let's see it in action. All right. So let's see. So here you can see I'm currently looking at a threshold alert, and I am choosing a metric called total receiver accepted spans. So we like this is something that, okay. My internal service is generating spans. We use Open Telemetry and SigNoz itself to monitor our own SigNoz, which is cool. So our
Monitoring the
internal,
monitor.
yeah, monitoring the monitor, and so our internal services produce spans, and then they the kind of how many spans they produce per second. It kind of varies, and if you can see here, so this is like this is the end result of that. If you see it here, it kind of shows a pattern, and during the night it's a little lower, and at the and during the day it goes up, kind of fixed. So this is what you are seeing, the last 1 week value. So you can't put a fixed threshold alert on this, because like what would you put, like if you put like something like 2000, it's going to give you an alert. Like there's no way that we can arrive at some sort of fixed threshold value that will alert you and not give a false alerts.
What's the
uh,
reason you would like to set an alert for this? It is
so
span coming from your services, right? So what are you trying to detect if you want to set an alert?
Right. So the what we were trying to detect is that if my so the number of spans generated indirectly gives me the kind of so if I am generating these spans, and it kind of gives me the how much request that I'm handling. So if I get a if the service is producing this many times, it's kind of translates to request, and I kind of expect it to be okay. So if my service is receiving this many requests, and if it's unusually, let's just say, for some reason it has received unusual number of requests, and I want to be notified about it. I know, like having that, let's say if somebody tells me that, okay, the request rate pattern for this service has gone up unusually, like this is not something we expect, and then it may be that somebody is doing a DDoS attack or something else, we don't know. So it's good to have that ability to set an alert on the incoming request rate.
Got it. But you still know that there is a certain pattern which this service follows. So how do we incorporate that pattern when you're setting the alert so that you also don't get too much alerts, right? Because I know many times our engineers are also getting bombarded with lots of alerts, and it's a problem, right? Like, how do
Yeah,
you
the
know
alert
which are the right alerts?
problem.
Which
Yeah.
are the right alerts? Are you getting falsely alert? And many a times I have seen people just disable an alert if it is sending too much alerts.
Yeah,
But the
that
problem is it may miss some of the actual relevant alerts. So I think this anomaly detection based alerts would help people get less alerts in the first place, and also more relevant alerts, like not just fixed threshold burst alerts. Sorry, continue, Srikanth.
Yeah, sure. So this is the fixed threshold alert, and if I go down here, it asks me like, hey, give me the alert threshold, and I
So
can't,
what
I
what
can't.
happens if you send a threshold of 2000, which seems to be
Uh,
like the mean value?
so let me try to set a threshold of 2000, and if you see, it's not
Yeah,
something that it's going to send alerts too
not at all
often. That's
useful.
the thing.
Yeah, it's not
It's
at
not,
all useful to
yeah.
set alert using this. Got it. Cool.
So let me go through the let's switch to the anomaly detection now, and let's see how it kind of helps us, kind of figuring out where the how to identify those anomalous behaviors. So I will use the same metric, and I will try to see what it would show me if I use the anomaly metric. Yeah,
Cool.
in this, like with the new, when I switch to the anomaly detection threshold, now you can see that, hey, it's giving me four, like there are four line charts here. The one, this is the actual metric, and then there is a predicted one, and we have the upper bound and the lower bound charts. As you can clearly see here, that the during this period on the September 8th, from the 11 o'clock to like till around 10 o'clock, there was clearly some sort of the volume of the scans that were generated were much higher than they were expected. And if you compare it with the rest of the week, like on the, like on this day it was not, it was fine, on this day it was fine,
Yeah.
every on the rest of the, as a whole week it was all fine except just this day. So there must be something that must have happened on this day, and you wouldn't be able to identify this with the fixed threshold without getting bombarded. So this is where the we the anomaly detection kind of comes into save your day here. You will only be notified on the day where on the 8th September, where the expected value and the predicted value are shown, and then the actual value is above the upper bound. So if you can see, it's clearly out way higher than. So let me zoom
Yeah.
in to kind of give you a much clear picture. Yeah, as you can see here, so there is a kind of pattern that the predicted one that shows on the lower bound and upper bound that we expect it to be, but the actual value is much above, higher than the what we were, even the upper
So
bound
it's
allows it.
consistently higher than the upper bound and the actual predicted value, right?
Right. Yeah, so
Got
this is kind of, yeah, clearly telling you that so this is something that, hey, I know I do not expect, like this is kind of clearly indicating out of all those days, given that I have a kind of pattern that I expect the daily to be repeating, on just this particular day on the 8th September it did not do that. And you would want to be notified about such scenarios to go and if it were a DDoS attack, you'd have to act on it. Or if it was a genuine, you may it may be something, if it's a genuine traffic that you're getting, some downstream services may be affected because of the unusual volume, and you may want to get notified earlier before that, and then realizing that the issues caused later. So this is where the anomaly detection comes and saves your day.
Got it. How do people set this up? How do people specify the thresholds, etc. for this?
Yeah. So let's look at the condition part. So in the alert condition part, what we allow is, okay. So here you have the set notification when the observed value for take a particular query that you are interested in getting alerted on during the last 5 minutes. So this is the time of the, like, the window of the data that you want to, hey, look at the 30 minutes data, and if the predicted value goes above this far, like longer, just consider this window, don't take too long, is like X standard deviation. So this is where we allow you to consider. If you set it to be too high, you will not be notified at all, and if you set it to too low, you may be notified very often, which you want to avoid. And in the here you have the options above, below, or below, and you can choose any of them. Like sometimes you may tolerate it going higher, but you do not tolerate it going lower. So like, for
Mm.
example, let's just say you expect the service to be receiving this many requests all the time, like at least it should never go below. Let's just say your transaction processing system or something that's emitting some metric, you do not expect it to go below the threshold, and that's kind of the lower bound. So you can either choose above, below, or if you are interested in absolute value, you do not bother about the direction in which the metric either spikes down or spikes up, then you can choose the above or below. And you can either choose, okay, do you want to be notified if it goes above at least once, or it has to go all the times above the below the threshold. So the using the standard algorithm. So this is one we just discussed. And we also allow you to configure the seasonality. So here you have the options of hourly, daily, and weekly. So this will tell us, okay, so what is the past seasonal data that I should consider to arrive at the predicted value.
Got it. Yeah, I think this looks pretty cool. I think it would be very helpful for customers. One thing I can think of is that, hey, like why do people need to set up the seasonality themselves? Can the algorithm be intelligent enough? I think from a technical perspective it gets challenging because you don't have any context on what the underlying nature of
Correct.
the pattern is. For example, I would guess in December, every like any e-commerce will see more traffic, but that is different than say the weekly ups and downs which you see in a like daily weekly traffic for a e-commerce site, right? But I think maybe some area where you can work on to see like can this be completely automated? Is this
Yeah, that's
cool?
true. Like, yeah, that would be very interesting thing to have. Like, one, like one next, like the kind of next iterations to is to have that. Hey, this is what what I believe it to be the seasonality, and you can go ahead and if it's correct, keep it correct, or if it's not correct, change it, and then we kind of use that as a data point to consider that, hey, we were expecting it to be this seasonal, but user changed it, so it's something that we take it as a data point to improve upon.
Yeah. So I think we introduced one more like anomaly detection as the next part. What are the other plans you have in the future for this? Like where do you see this feature going? Because as we discussed, this is sort of the first setting up base for more advanced, more intelligent alerts. What
Right.
other plans you have in this?
So yeah, so the next set of things that we have on our roadmap are the outlier detection. Anomaly detection is obviously useful. It's and there are cases. Okay, hey, I don't want. I want my. I have n number of services, and I expect them to be processing the. I expect them to be behaving in same. Like there are, let's just say I have my service running on 10 machines, and I expect all of them to be behaving in same. Like I have a database application that has three shards, or let us say I have database service that's running on n number of shards, and I kind of expect them to share the load and behave in comparison, like they kind of exhibit the same behavior when compared to their peers. If they do not, if let's just say one of them is kind of outlier, let's just say particular take a particular shard, like shard 2 started degrading the performance, and it has become extremely slow, and you want, and there you want to be notified about, hey, this is the in overall, this is the kind of outlier that in this metric, only in this metric, then you have the shots, and then get notified when if the one of them deviates from the rest of the group of the labels that you have. It could be shard, it could be like if your application service, it could be like in the context of your metric, it can be anything. And
Yeah.
that's one area where we think will be very useful, and we have seen some users ask for it. So there's definitely a need for it.
Yeah, I think change detection or is also like alert based on changes. Like if you see a difference, then you see. I think that's also we have seen from a community and users is one area. I think you can already do that today in the alerts, but maybe it will be just a lot more simpler for users to create alerts based on that.
Right,
Uh,
that they can do it with the time shift. We have introduced a
yeah,
bunch of functions that you can work with, and one of the functions is time shift operator. You can say, hey, shift my metric by this time, and then try to show me what it was, like 2 weeks, 2 days back, or 2 weeks back, or whatever the time, custom period time, and it kind of compares you can say, hey, if it's kind of from the time shifted by, if it changes value by this much, get notified about it. Yeah, that's achievable, but it's not discoverable, and the user experience can be made much better.
yeah. I think one question I had is what if the prediction or like what if the anomaly detection, which is predicts between upper bound and lower bound, is like something which users expect, right? For example, how can users give feedback to this model to make it better? For example, if in your example, right, if we go up for this example only, yeah, just go back to the 1 week time window where you had like the complete seasonality. Yeah. So I see also like say around 7th September, the actual is crossing the upper bound, right?
Yes, correct.
Yeah. What if this was what users were okay with? How do we make the model better based on, hey, like taking inputs from the users, right? Is this
Right.
is this easy to do, or how does that, or do you have some thoughts here?
So we have, so the whatever the value that, like, okay, so the upper bound value that's kind of predicted, so obviously the G score threshold that we are giving you, the bot at the bottom, is going to allow you to control that. But then
Yeah.
again,
Yeah, but
the
then that would make everything very wide, right? What if they just
very,
want to include this type of pattern? Maybe this is some pattern in their data that, hey, like around 6, 7 p.m., where we can expect some extra load. Can users give that, or is this very difficult to incorporate in a like algorithm like this?
right now it's a kind of very
Static
simple
model.
statistical
Mhm.
model, and it's not easy to kind of, if we start doing that, and it's kind of becomes a rule based, which is not going to be very good in the end. There's going to be it's not going to be scalable solutions to kind of allow to do in this current statistical mode.
Got it. Got it. Cool. Yeah. Thanks for sharing this. I think this looks pretty interesting. Would love any for users and viewers to check this out and give us any feedback. I think we are just starting on building the initial versions of intelligence in our alerts. So, what type of use cases you have, please reach out to us in our community. Uh, and then we would love to hear more about how you are finding this useful. Any like comments from you, Shrikant, before we close?
Yeah, same. Please, we're going to we are actively working on make this get this out. Like we demoed it, and we would like to hear feedback around this, and any other kind of request that you may have. Like what would you like to see in SigNoz already?
Cool. Yeah. Thanks, Shrikant, for joining, and thanks everybody for joining for the webinar. See you again.